Hey everyone. So this video is about the sum rule and partitions. The sum rule is a counting principle that may seem really obvious to you when you first read it. It basically says to count a collection of objects, you just need to break the collection up into smaller groups and add all the numbers you get from each group to get the total. And really that's it. That's all the sum rule says. Consider this example. So this is a familiar sight to many of your instructors and TAs. A class has just had their final exam, and I would like to count how many students took the exam. Now, there are a number of ways I can do this. One way is, well, I can simply count all the papers one by one until I get to all the papers, right? So I can be like 1, 2, 3, 4, 5, and so on. And however, if I get distracted, I'm going to lose track of where I am, right? So that's really annoying, and that's not really a good way to count. Another way that you see in this picture is, well, we can separate all the exams into piles first, and then count the number of exams in each pile. So for instance, this pile could have maybe 56 exams, this could have 53, this could have 68, this could have 60, and maybe that last pile is 55. And after this, we can add all the numbers up to get the total, right? So this is a much more efficient way of doing it, and you don't run the risk of losing track of counting close to 300 exams. In fact, you can even separate all the exams into piles that have the same number of tests, right? So this is what me and my TAs usually do, in fact. We count piles of 10, and at the end, well, you just need to multiply 10 by the number of piles you have and add any leftovers to get the total. This is the sum rule in action, right? And what the sum rule says is, let's go back to the statement. If we are able to partition the things we are counting into disjoint sets, then we can just count each smaller set individually first. These are your BIs, so B1 to BM, and then just combine everything together afterwards. Essentially saying that a problem may be made tractable if we can break it up into smaller cases, right? So instead of counting this big collection, right, if you know which cases to break it up into, that might make the problem easier to deal with. Now, this is important, the word partition here. It's very important to check that these cases, or these sets B1 to BM, do form a partition of what you're counting. And to demonstrate this, let's look at another example. Okay, so take a look at this. How many students are taking a 200 level math course this term? So what are the 200 level math courses? So we have, say, MAT202, 223, 224, 232, and a whole lot of others, right? So I'm not going to write all of them down. Now suppose we knew how many students were in each course, right? So MAT202, let's just say there's 100 of you right now. For 223, maybe 400, 150 in 224, 500 in 232, 90 in 244, and so on. And so now the question is, can we apply the sum rule? Can we answer this question here by simply counting and adding all these numbers up, can we apply the sum rule? So think about this for a moment and pause the video right now. Okay, did you try it? The answer here is no. We cannot apply the sum rule. This is because we don't have a partition of the set that we're counting, which is the set of all students taking 200 level math courses this term. I mean, just look at these numbers, right? So let's take these two courses in particular, 202 and 223. The set of students who are taking either of those courses well, the sum rule would say it's 500, right? If you knew that these 100 students and these 400 students form a partition. In other words, they have no overlap, right? They are disjoint sets. But in fact, we know it's highly possible that there may be students in MAT202 who are also taking MAT223 in the same term, this term. So the number of students taking either of those courses is probably smaller than that. And so we cannot apply the sum rule for this particular problem. Exactly because we don't have a partition. This is why checking that you have a partition into disjoint sets is very important before you can even start adding numbers up to apply the sum rule. Right? And so just to review, what is a partition? Well, if you have a finite set A, we say that B1 to Bm form a partition if two things are satisfied. Number one, all these sets are disjoint. And number two, the union of all these sets must give you the original set A. All right, so as a diagram, this is what it looks like. If this is the set A, it's B1, B2. Any element in A can be located in exactly one of the BIs. And if this is true, then you're free to apply the sum rule.